Hello everyone. Today I want to talk about adding and subtracting roots. Roots when it comes to numbers with the radical or square root symbol or cube root or fourth root symbol in them. You can almost think about roots as you would fractions. Similar to where you have to have a common denominator or your fraction has to have the same base, if you will, to add a fraction or subtract a fraction. You have to have the same idea with roots. When you deal with roots, as long as you have to have the same number, including number and variable underneath that root to combine them with addition and subtraction. If you don't have the same underneath, you cannot add them together. So if you have something, to give an example of, let's say, 5 square root of 11 minus 2 square root of 11, we can just combine them because under the square root is the same, 3 square root of 11. 3 square root of 11. Or if you have, let's say, 14 square root a, b, minus 11, and let's make that minus 7 square root ab. Notice that the square root is the same on each one. Since it's the same, we don't touch it. We have to say 14 minus 7 to give us 7. So that's pretty straightforward if you have the same thing underneath the square root. Basically, add or subtract them as you normally would add or subtract anything else. If you don't have the same underneath the square root, then you have to see if you can make it the same, using strategies as you did for simplifying radicals or simplifying your roots. To give an example, let's say you have 3 square root 28 minus 13 square root of 7. Now obviously 7 is not the same as 28. However, we have to see if we can make them the same. Well, if you look at the numbers 28 and 7, ask yourself, is 28 or is 7 a factor of 28? Or can you divide 28 by 7 and come out with a integer, a non-fraction, non-decimal number? Well, 28 divided by 7 is 4. So we can see if we can change that and make that 4 times 7 minus 13 square root 7. Now, still not the same, because you notice we still have this difference underneath the square root. Well, now in this case we can say, well, we can simplify this. We know the square root of 4 is 2. Now, once you know that, you can say, well, that's 3 times, so changing square root of 4 into 2, square root 7, minus 13 square root 7. We're still not 100% done yet because we have to do 3 times 2 to simplify that, make us 6 square root 7 minus 13 square root 7. Or, since we now have the square root, 6 minus 13, well, 13 is larger, so the answer will be negative. Similar if you had wanted to buy something that cost $6. Or you wanted to buy something that costs $13. Remember, buying money is kind of like going into debt, or buying stuff is going into debt. And you only have $6 in your wallet, you are 7 short. So again, the big thing is when you're adding and subtracting, you don't have the same amount underneath the square root, like the 28 here and the 7 there. What you need to do is actually just make them the same in this case. Once you make them the same, then you can subtract them or add them, whatever you need to do. Now, the other thing that may come in, kind of combining a couple things together here, is if you have to multiply 2 parentheses worth of exponents. So let me just write down an example here. Okay, so 3 minus square root of 7 times the quantity 3 plus square root of 7. Now, normally you would say simplify whatever inside the parenthesis. Well, you notice in this case, because you have a integer, 3, and a radical, square root of 7, you can't add them. You can add them together to get an approximate number, but you can't add them together to get an exact answer, which is what we're looking for here. So, does that, if you've done foiling, that should look very familiar. You have two things where you can't add them together inside the parenthesis, there and there, and they're multiplied. Remember, we have two parentheses and there's nothing in between. You assume multiplication. So in this case, we need to do the FOIL method. And just as a quick reminder, FOIL method means first, outer, inner, last. So you multiply the first two things together. So we got 3 times 3. 3 times 3 in this case is 9. You have 3 times square root of 7. Now, the thing is that 3 is outside the root. 7 is inside the square root. So you have 3 square root of 7. So that's your outer term. Then you have to do your inner terms. Notice that there's a negative here, so it's minus 3, 7. And then finally, you have a minus and a plus, which will give you a minus square root of 7 times square root of 7. Next thing we need to do is simplify, as we're not as simplified as possible here. So, if you remember your order operations, please excuse my dear Aunt Sally. Purple eggplants make delicious afternoon snacks, and they do, they really do. You have to do parentheses, which we have none of here. Exponents, which we have none that we can, none that we can do here. Then multiplication. Well, we do have multiplication over here. Square root of 7 times square root of 7. So, we're going to do that before anything else. One step, one procedure at a time. Again, humans cannot multitask. You think you can multitask? You can't multitask. One thing at a time. So in this case, we have square root of 7 times square root of 7. Well, we can combine them under one square root and do 7 times 7. 7 times 7 in our case is 49. Well, luckily, we know the square root of 49. Or if we don't know the square root of 49, we can look it up in the table, look it up on Google, SQRT parenthesis 49 and parenthesis will give you an answer. There is a built-in calculator there. Windows, Mac, I'm sure it's in Linux. I haven't used it, or Unix. There's built-in calculator. Square root of 49 in this case is 7, which makes sense since we multiply square root of 7 to get that. So doing our square roots here and writing everything else and leaving it the same. So now we have to combine our like terms. Remember, like terms have to have this. If there's variables, the variables have to be the same. And if they have roots, the roots have to be the same so we can add and subtract them. So in this case, we have a constant and a constant, 9 minus 7, which gives us 2. And we have 3 square root of 7 minus 3 square root of 7. So you have something minus itself. You have like 2 minus 2. Well, 2 minus 2 is 0. You have 2 apples. You eat 2 apples, or take away 2 apples, or give away 2 apples to 2 people who need apples, and you're left with no apples. Well, here you have a 3 square root of 7. You have a minus 3 square root of 7, so it goes away, so your overall answer here is 2. Now you think, oh, every time I FOIL roots, I'm going to get rid of the roots. Not necessarily true. That's only if you have the same values, and the only thing difference here is the sign. So if we were going to change this problem around a bit here, I'm going to make a very, very minor change here. Unfortunately, it's a lot of erasing, but it's a very minor change to the very beginning. I'm going to make this plus. So we're going to FOIL again. So we're going to do 3 times 3, so we're going to have 9 here. 3 times square root of 7, well, it's positive 3 square root 7. Then we're going to have positive 3 square root 7, and then plus square root 7 times square root 7. Same procedure again. Notice that just because I change things, the procedure or how I do something, not what I do, but how I do it, is the same each time. We have to do our multiplication first. So again, this gives us square root of 49. Rewriting everything each time. So many people get into trouble because they're lazy, Lazy. Because they don't rewrite a step every time they have to. I'm guilty of it as anyone else, especially when I was in college. I tended not to double check my work because I knew I was right. I wasn't. Or just try and do it that way. So here we got rid of our multiplication. Well, we got to finish that still, so it's plus 7. 9 plus 3, square root 7 plus 3, square root of 7. So now what we have to do is combine our like terms again. Well, we have 9 plus 7 this time, which gives us 16. We have a plus 3 square root of 7 and another plus 3 square root of 7. Well, notice our roots are the same, our radicals are the same, so we leave that alone. And we have 3 plus 3, or 6. So you notice that little sign difference completely changes our equation here. Remember, watch your details. The big thing here is when you add or subtract, roots, radicals mean the same thing. The underneath has to be the same for you to do addition. If they aren't the same, such as our answer here, we cannot combine this anymore because there's a square root of 7 here and there's a constant without a square root. So this is our ending point here. Have any questions that I didn't cover? Put it down in the feedback down below. It's down here, okay? Have any other suggestions? Please leave in the feedback below. Otherwise, thanks so much and good luck.